My name is Ole Grønne. I'm Vice President of Marketing and Sales of MAN B&W Diesel Denmark, responsible for sales and marketing of marine and stationary diesel engines. Here we are in Copenhagen, very close to the city center, beneath what was at the time the largest diesel engine in the world. It was built by Burmeister and Wain in Copenhagen, a Danish engineering company which is still existing now as MAN B&W, and it is still a designer and maker of large diesel engines, primarily for ships' propulsion systems. Maybe you know a piston for your car, which is about the size of a big fist. This is a piston for the engine that we are going to discuss here. You'll see an upper part of the piston and a lower part of the piston. We have a double-acting diesel engine. We have combustion at the top of the piston. We have combustion at the lower part of the piston. The engine is from 1932, and it served the Copenhagen municipality as electricity generating machinery for about 40 years. And later on it has been kept in good working order all the time by the crew here, and it has been used occasionally for start-up. A few years back we had a very big blackout in the Copenhagen area. Then it was used to re-establish the grid frequency and used for synchronizing of the other electricity producing units in the system. Now we're at the location where the engine controls are. This is where you start the engine, and here you can see a graduated scale from 0 to 100% in load. And here you have thermometers showing the temperatures of the combustion chamber up, top and down. And we have here also the temperature of the fuel oil, the lube oil, the cooling oil and the cooling water and so forth. We have various temperatures to monitor what the engine does. Here we have the meter showing what power it develops in megawatt, and here we have the RPM. The engine have 8 cylinders, each with a piston diameter of 840 millimeters. And the stroke of each piston is 1500 millimeters. That's a little less than my height. It is so that this engine is actually a double-acting diesel engine, which is not used anymore, but that was the only way to boost power in the old days. Nowadays on modern engines, an engine of this size would have a power which is 3 times higher, maybe even 4 times higher, by using an air supply system using a turbocharger. The air supply system on this engine is made by what was called Roots blowers, and they are driven by the engine. You will see here you will have the piston rod, you will have the cross member which draws the rods that draws the upper cross member that drives the upper piston and the exhaust piston. And it is so that here you'll see all the parts which are not very easily accessible for overhaul. And that is also, in fact, why the room here is a little bit smoky, because things like that, they tend to leak, and that is what we see in this heavy sunlight that we have today. MAN B&W has recently developed electronically controlled engines, which does actually have fully electronic and hydraulic control, and this means that we have much better control of the combustion in modern engines than we have on this older engine of today. The reason for doing that is that in today's environment, it is absolutely necessary to be able to control combustion in such a way that the engine can comply with environmental expectations, both with regard to sooting and smoke visibility and so forth. Today's demands are much stricter than it was 70 years ago when this engine was built. In Denmark, this engine is considered a national treasure, not least because the company who built it and designed it, they are still around and has been so for 100 years, making diesel engines for stationary and marine application. Nowadays, engines of the same principle, of course in modernized execution, can develop up to 100,000 kilowatt per unit. And they are produced primarily in countries where ships are today being produced. And this is Korea, Japan and China. There's a few makers also in Europe, but it is in Asia nowadays that the main market is for the application. Now we're at the top of the engine, and it could be interesting to discuss why do we actually use diesel engines. A diesel engine is the most efficient thermo engine that exists, and it still is in today's market. At its time, this engine could actually supply enough power for Copenhagen city, which is not the case today. City is larger, people have more appliances, they use more power. But diesel engines of this particular type, of course a modern execution, are still being used for power generation on island communities, on isolated communities where they are not connected to larger grids. The engine that you see is 12.5 meters tall, it is 24.4 meters long, and it weighs 1,400 tons. The heaviest engine or biggest engine so far built has a weight of more than 2,000 tons. It has a piston diameter of 980 millimeter, and it develops more than 100,000 horsepower.